Okay, at this point, we have done 2 lessons in class that discuss what infinity meant and what 0 plus and 0 minus, and even, of course, negative infinity. And so we're going to take it a step further and look at a term called limits. Limits basically are asking you to think what's happening as I get very, very large, or as I get very, very large negative, or as I get incredibly close to 0 without actually getting it from the positive or the negative side. So when I ask the question, limit as x approaches infinity, what that's saying is, what is happening as that number, replacing x there, is getting larger and larger and larger? Or if it was negative infinity, it would mean as I'm getting larger and larger negative-wise. Or if I'm talking about 0 plus, it would mean what happens when you put a very, 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 very small number in that spot. And so we're going to look at a few examples here. Let's just start with limit as x approaches infinity. We're going to do a few of these. So limit as x approaches infinity. In all essence, what you're going to do is you're going to replace x with the infinity. So this is infinity plus 2. Well, we've talked about the fact that infinity is like the ocean. And so when I say that, what I'm talking about is if we had the ocean and I took little 2 eyedroppers and I just put 2 little drops of water in there, what would that do to the size of the ocean? Would that change it? Absolutely not. It's still infinity. How about if I took infinity and I took away 2 eyedroppers of water? Of course, it wouldn't do much to the ocean. You wouldn't even see the levels change, right? If I said to you, limit as x is approaching infinity, but now I've got 5 minus x, so that would be 5 minus infinity. The only thing that I would say about this that we have to be careful of is we see that it is minus. And it helps, especially if you know your sign rules quite well, because your sign rules allow for you to see, oh, wait, the bigger one is here, of course, with infinity, and it is now negative. The answer to this one would be negative infinity. Just to move this guy out of the way, let's do the next one. The limit as x is approaching infinity for infinity divided by 5. Well, infinity divided by 5, if you take the ocean, you divide it into 5 sections, it's still huge. You still can't fit it in your backyard. You follow what I'm saying? And then we'd have 5 divided by infinity. If I was to use this illustration, to me this kind of relays it the best. If I ordered 5 pizzas here, so I just called up Papa John's or Brenda's or some local place and said, all right, I want 5 pizzas. And I put those 5 pizzas on my counter and I said to you, all right, you know what? Everyone that comes is going to get the same amount of pizza. I'm going to distribute this equally. So, of course, if one person shows up, what does that mean? That means everybody gets their own pizza, right? There's 5 pizzas. Everybody's going to get their own. If 2 people show up, what just happened is now your size of pizza that you just received just got cut in half. If I said, all right, well, you know what, 5 people showed up. Well, you're like, oh, that's still all right. I still get 1 pizza. But what's happening to your size or amount of pizza? How about if I said, you know what, 10 people show up. You now get half a pizza. Or if I said 100 people show up, what just happened there? Yeah, so what's going on here? What if it's 1,000? What if it's 10,000? And you can keep seeing that as this number here in the bottom, what's going to happen to it is your amount of pizza is getting smaller and smaller and smaller. So 5 divided by infinity would be a very, very small number. And how do I express a very small number? 0, yes, but we would say 0 plus because it's positive. Good? Let me just make sure there's any more examples here. There isn't. All right, so now let's regroup here. Let's do this again, but now let's do it with negative infinity. So we're going to do the same questions, but now negative infinity. So I'm going to do negative infinity plus 2. And of course, that would just be negative infinity. If I had negative infinity minus 2, it just made it a little bit more negative, right? That doesn't really change much. If I had 5 minus a negative infinity, well, see, your sign rules still work here. So when you have a minus and a minus, it does in fact make that positive. And so that would be positive infinity. Negative infinity divided by 5. I mean, infinite amount of pieces divided by 5, it's still very, very, very large. But the sign rules, again, still apply, so it's negative infinity. Now, how about this one? We talked about the fact that 5 over infinity would be very, very small, right? It'd be close to 0. When you put on the negative here for negative infinity, instead of it being 0 plus, it'll be 0 minus. A very, very small but negative number. Let's look at some more examples. Now let's plug in some numbers because it doesn't just have to be infinity. So let's look at this one. And what 3 plus means, I don't want you to think positive 3. I want you to think slightly bigger than 3. So 3 plus means like 3.00001. Okay? It's slightly bigger. And when we're dealing with sign rules, and that's really, in essence, what you're dealing with here. You're really examining your sign rules, and if you know those. So those of you that have struggled with sign rules, this is your chance to make sure that you learn them. What we have here, just like before, you're going to replace x with that limit. But what this is saying is this is slightly bigger than 3. So when we're adding or subtracting, the one that is bigger gets the sign, correct? So if 3 plus is a positive number, it is bigger, and therefore my sign here would be 1 over, see, 3 minus 3 is 0, but it would be 0 plus. Do you follow that? We know 3 minus 3 equals 0, but when we put that 3 plus on it, that means that, yes, it's close to 0 still, but it's slightly bigger because this one has slightly more. Okay, and if you were to look at it with numbers, with 3.00001 minus 3, you'd be left with that 0.00001 is what you'd be left with. So let's continue on with this kind of question here. Well, what happens when there's something in the numerator like you see here? See, we would still replace that with 3 plus 1. And yes, you could still put the 3 plus. Let's just do that so you can see what's going on here. But the truth is that 3 plus only matters when it makes the denominator equal 0. As far as the numerator goes, we can treat that just like a normal 3. Because the truth is, it is just a normal, it's just approaching that number, and that's all it's doing. When we look at the bottom, we understand 3 minus 3 is 0, but is it 0 plus or is it 0 minus? And of course, the question is, which one is bigger? And of course, 3 plus is bigger, therefore this would be 0 plus. Well, now this goes back to earlier questions where we're looking at, and I didn't answer that above here, where we had 1 over 0 plus. What does it mean when you have 1 divided by 0 plus? Hopefully we've answered this already. So a number divided by 0 plus we know as infinity. As those numbers get very, very small in the bottom, what happens? Of course, it gets very, very large. So let's keep going. So then I would have 3 plus minus 5 over 3 plus minus 3. 3 minus 5, well, that's negative 2, right? 3 minus 5 is negative 2. And on the bottom, we understand that's 0. Again, is that 0 plus or 0 minus? Correct. Now, we understand any number divided by 0 plus makes that infinity, but this would be negative infinity because our sign rules do still apply. All right, let's look at the next one. 1 over, and again, we would have 3 plus minus 3, but it's squared. Well, that doesn't change the fact that inside there would be 0 plus, and when we square it, guess what? It actually just got smaller, which there's no better way to express it than just to continue with the 0 plus, so this is just positive infinity. Okay, same questions now, but we're going to do it with 3 minus. How does that change things? Well, let's look at it. So we'd have 1 over, we'd have 3 minus the minus 3. Let's think back. What does 3 minus mean? Does it mean negative 3? Nope. What it means is slightly smaller than 3. So 2.9999999, very, very small difference between that and 3, but it is slightly smaller than 3. Again, we know that 3 minus 3 is 0, but now the question is which one is larger? And of course, regular 3, if you were to compare 2.99999999999 and 3, the 3 is larger and its sign is negative, therefore that would be 1 over 0 minus, making that negative infinity. Contrast that with what we just did with the 3 plus, and you'll notice that the sign made all the difference. All right, let's look at the next one. You'd have 3 minus plus 1 over 3 minus minus 3. And again, it doesn't affect the numerator at all because it's not really where the problem lies. We've got the 0 at the bottom, and again, we recognize from the question before that that would be 0 on the minus side. And just because it's 4 divided by 0 minus doesn't change the fact that it's going to get incredibly large as we divide by smaller numbers. 3 minus minus 5 over 3 minus minus 3. And again, we'd have negative 2. And on the bottom, you'd have 0 on the minus side. So again, we know it's infinity. Is it positive infinity or negative infinity? My hope to you is you recognize the sign rule. We've got a negative 2 and a 0 on the minus side, which means this is going to be positive infinity. Last but not least, you have 1 over, and we'd have 3 minus minus 3 squared. Well, again, we've done it enough times to recognize that that would be 0 on the minus side, but we're going to square it. And whenever I square a negative, it becomes positive, and so this answer would also be positive infinity. All right, so how does that affect if I just had 3 regular, no plus, no minus? Well, the difference is with this, and let me just, I couldn't emphasize this enough. If it does not specify plus or minus, then you must look at both. If they agree, that's your answer. If they disagree, then it does not exist or is not able to be determined. Okay? So you have to look at both. Now, what do I mean by that? Well, if we were to look at the limit as x approaches 3, we understand this is 1 over 0. So what I've got to do is I've actually got to look at 3 plus and 3 minus. If they agree, then that's the answer. So we already did these, so I'm not going to, do it over and over again. We understand that from before, if you were to go back through this video, you'd recognize that we got infinity with 3 plus, we got negative. They do not agree, therefore it does not exist. Let me give you another example here further down. If I was to do 1 over 3 minus 3 squared. Again, you understand you got 1 over 0 squared, and sure, that's 1 over 0. But again, we don't know which way that goes. It's undefined at this point. So we have to look at 3 plus and 3 minus. Well, when you did 3 plus, you had 1 over 3 plus minus 3. You had 1 over 0 plus, and of course you'd square it, which gave us 1 over 0 plus, which was infinity. When it was 3 minus, what happened was you got 1 over 0 minus, but when you squared it, it became 0 plus, which makes that also positive infinity. Since they agree, it's that answer. It is infinity in this case because they agreed that it was infinity. Do you follow that thinking? So if it doesn't tell you, you have to look at both and then see if they agree. I'm going to make this one really quick, this piece. The last thing that we're going to talk about today is indeterminate forms. Indeterminate forms is basically you've got infinity and you've got negative. Which one is it that's going to win? Which one, is it going to be positive infinity or is it going to be negative infinity? And of course, both of these present the same kind of scenario. Infinity minus infinity. And of course, it says negative infinity plus infinity, but that means the same thing, commutative property, right? So we can see that by switching the order, as long as those signs are maintained, again, it's the same question. And if I could coach you in some way, the highest power wins. Well, what if we're not talking about powers? Well, then the strongest function wins. And you're like, well, how do you know? Well, I said strongest power. I'm going to put strongest function. Well, here's a rule to live by, okay? E to the x is your strongest function ever. It climbs incredibly fast. Your exponentials, if you were to look at the graph, we're talking about the strength of how fast does it climb. It climbs incredibly fast. And so if you can just understand that if it's e to the x and x, e to the x and x cubed, e to the x and natural log, e to the x and sine x, e to the x and whatever other function, e to the x is going to win. If we're talking about highest power, what that means is like x to the 4th and x cubed. Which one's going to win? X to the 4th. So if I had x to the 4th minus x cubed, and again, that would be infinity minus infinity, the highest power, x to the fourth, the one that has positive infinity, is the one that wins. If I had x cubed minus x to the fourth, again, you have infinity minus infinity. But the highest power here is x to the fourth, and it is negative. Therefore, this answer would be negative infinity. So as you look through the examples in your homework assignment today, the idea is highest power wins. And if it is positive, so is that infinity. And if it was negative, then that's the one that receives the sign. Hopefully that makes enough sense for you to be able to accomplish your homework questions sufficiently.